We are recording for Algebra 2, the final review, the final review. This is it. This is the final moment. I'm surrounded by 10 billion of my students that have waited to the literal last minute to actually learn this stuff. The challenge right now will be, can they learn all of it a semester in 3 hours? That's the challenge. We'll see how it goes. All right. For those of you that are participating in said review, I need to know, what quiz would you like to start with? 8. Okay, I'm hearing 8. Are we doing the whole, like, do every one of them thing, or are we doing requests? And if you want other ones, I've already done them all on the other recordings, right? So, 8, do we have requests, or we just want to go in order? What do we want to do? I think just let whatever the wind takes you. That's not what's happening. I've done this. Yeah, if that's what everybody wants. Is that what we're cool with? We're skipping the basics? Okay. Real quick.
You want for I will be like and go right. If or you understand like how I understand like that. No. 9.
8.
8.
But yes.
What yes?
I understand.
Okay, and I may left just said.
Yes. All right. So, do we need to talk about 814, yes or no?
Yes.
All right. Furthest from the origin. Isn't the origin 0, 0? Yes, it is. We need to do distance formula with this. This is not hard. If I'm starting on 0 and going to 0, the distance is 0. If I'm starting on 0 and going to 4, the distance is 4. We do pfag to find the actual distance. Oh my God, it's 4. Because 16 rooted is 4. So this is 4 away from the origin. That shouldn't shock you, right? This one, though, is going to be a little bit weirder. It's not going to be 2 away. It's not going to be 3 away, right? 0 going to -1. What's the distance? 1 or -1. It doesn't matter because we're going to square it. 0 going to 2? 2. Our distance is going to be the root of 5. Now, which is bigger, 4 or the root of 5? Which is bigger, the root of 5 or 4? 4 is bigger. Root of 5 is 2 and change, right? So this is still the furthest away. Do you think this one's going to be further away than this one from the origin? Yes, right? Think about it. It's not only 4 to the left, but it's also 3 up. So it's going to be further away. The question is how much further? Let's find out. Between 0, 0, and 3, 4, -4, the distance is 3 and 4. If we square them, add them, and root them, we find our distance. Pythagorean theorem, that's 9 and 16. What is 9 and 16? 25. What's the root of 25? 5. It's further, a distance of 5. Right now, this is our winner. Do you think 4 and 1 is further away than 4 and 3? No. Probably not, right? So why check it? I think we found our winner. How do you feel about that? The distance between the origin and something is really easy to find because the origin's 0, right? That was kind of quick, but I wanted to grab your attention. Should I go slower on that one? Should we talk about it some more? Questions? No? All right. You want to see how to do 815? Watch this. Are you ready? Done. Did it. Done. All right, next question. Next question. It's the same thing every time. I can't change the numbers. Why would I include it in the final? Right? Don't do the next one. Kitson, you don't need to see the next one. Emily, think before you speak. Emily wants to see it. Fam, this means I want all of the points where y is -3. Emily, give me a point where y is -3. Say it again. I can't hear you. 0, -3, thank you. So, 0, -3 is here. Give me another point where y is -3.
1 -3.
Thank you. 2, -3, 3, -3, 4. Guess what kind of line this is going to make? Don't say a straight line, they're all straight. Horizontal line. So y equals -3 is a horizontal line because y is fixed at -3 and x can be anything. So what's the slope? How would you describe the steepness of this line? Nothing. It's not steep at all. What about x equals 5.8? Emily, give me a point where x is 5.8. Very creative. So we got 5.8, 1, 2, 3, 4, 5 and change, comma 0, 5.81, 5.82, 5.83. Hey, look, here are all the points where x is 5.8.
Oh my God, vertical.
It's a vertical line. Now, x equals 5.8. What kind of slope is that?
Not
Undefined. Undefined. Because it's something over 0, which doesn't make sense in numbers, but it does make sense for slope, right? Infinite steepness, 0 horizontalness. Yep, there we go. All right, moving on. All right, Emily Kitson and friends. Do we want to do page whatever this is? No? Okay, on God? Yes. Okay. Yeah, do it. All right. It wants you to estimate the slope and tell me whether it's greater than or less than -1 or +1, right? So here's the idea. Pick a point. Okay, I picked that point. Let's go delta x from here to here. Is this delta x positive or negative if I'm starting here and going there? Positive. What about delta y? Is it positive or negative? Going from here to here. You got to be consistent. Well, either go here, either it's double negative or double positive. Thank you. Okay. All right. Would you say delta y and delta x are equal, or is one bigger than the other? What do you think? If you really want to, you can say delta x is bigger. I would have taken equal, but that's fine. So give me a slope where the delta x is bigger than the delta y and both are positive. Delta x is bigger than delta y. Give me a slope. Rise over run. Delta y, delta x. Which one's bigger, delta y or delta x? So y is the bigger number going on top. Okay, so you said 2 over 3? Okay, that's fine. Okay, so there's our estimate, okay? This is 2, that's 3. That's our estimate. Samantha, since this is positive, is our slope greater than or less than 1? Good, awesome. I would have said it's equal to 1, but that's just me. You said it was less than, I'll take either. All right, which one's the line? Doesn't matter, they both have the same slope. What's the slope? What's the slope? Undefined. Thank you, Bripley. Bripley, where have you been? All right. Which one's the line? Doesn't matter. They have the same slope. What's the slope? 0. Thank you. All right. This one right here. 0 slope, right? I don't know which one's the line. One of them's the x-axis, but it doesn't matter because they're both going to have the same slope. This one right here is definitely the line. It's definitely a negative slope. You can tell because delta y is negative and delta x is positive. Or if you go from the bottom to the top, it's the reverse of that, right? So here is down to the right. This is left to the up. Hello. Thank you. Bye-bye. So I need a slope that estimates this. Can you give me a slope that estimates this? Yeah, so negative 2 over 3 perhaps. All right, so now we got to compare it to -1 because it's negative. So is our slope greater than or less than -1? Careful. Is this greater than -1 or less than -1? It is because it's closer to 0, right? It's further to the right. So this is greater than -1. Yes? Come on. Talking to the mic. Oh, sorry, I tried. All right, down here. Looks like this is delta y, this can be delta x, I don't know. All right, so is delta x positive or negative? What do you think? It is if we go left and then up. Okay, we can do that. Okay, fine. If that's how you want to view it, that's fine. It's perspective, right? Okay, cool. Give me a slope that could represent this. Hmm? All right, which is -6, right? So we got to compare this to -1. Is -6 bigger than or less than -1? Thank you. Good job. Delta y positive, delta x positive. Is that how we're viewing it? Go to the right and up? Okay, cool. Give me a slope that estimates that. Hmm? Yeah, rise over run. Okay. I'd probably say it's like 12 over 1, but either way, yeah. Right. Well, I mean, we're estimating. So let's compare it to positive 1. Is it greater than or less than 1? Because it's positive, we compare it to 1. If it's negative, we compare it to negative 1. If it's exactly 0, just write that. If it's undefined, just write that. So is this greater than 1 or less than 1? Thank you. Yeah, it's really steep. It's greater than 1, right? It's greater than 1. I am not doing 831 again. I've already done it on the other videos. Why do you got to be whiners? This is not hard. You already have notes for it. What's your problem? Oh, boy. Fine, I'll do it. Yeah, I'll do it if you want. Okay, cool. So am I skipping it or no? What? Yeah, you did this earlier where you have this problem. No, hold on. You did this right this time. Good. That's 12. Yeah, you're fine. Yeah, you did it wrong earlier, though, like yesterday. You know what I mean? Okay, no response. All right. You did it wrong on the quiz yesterday that you took. You remember? I wrote your notes? Yeah. Right. All right. Bozos and bozettes. Are we doing 833? We lost Samantha. If you gotta, I think you should just like let it go, man. It's all right. Okay, whatever.
Why are you so sassy, bro? You get a good grade on.
Oh my God, the things you guys will do for a grade. Grades are fake. All right. So are we doing this or no? I forget. So we're just gonna do 10. Yeah. You know. So we're going to 10, huh?
Do you think you could send me these too?
Yeah.
So that
Yeah.
I could,
Yeah. No, I'll take care of it. Yeah.
and wait,
Write your name on these.
oh yeah. And since these are both evidence.
Yeah.
And I did half of it like intermediate. Is that like a
That should. It's gonna be. I can't tell you that. Depends on a lot of things, but it will help.
oh my gosh. Papers.
Thank you.
You're welcome.
All right, Samantha's back just in time for us to go back to quiz 8. Fantastic. All right, Samantha, what else do you want to see on quiz 8? Do you want to see 833, Samantha? On page 11. Bye. I'm starting to recognize these by their numbers. All right. Does every line have both an x-intercept and a y-intercept? What is an x-intercept? What? What does that mean? If a line has an x-intercept, it means it hits the x-axis. Can you draw me a line that only hits the x-axis? Yeah, that doesn't go through 0, 0. Right? So does that have both? No. Does that have both? No. Boom. Anything like that will not have both. Okay. Does every line have both an x-intercept and a y-intercept? No. This one only has an x-intercept. This only has a y-intercept. So not every line will. Perfectly vertical and perfectly horizontal lines won't, as long as they don't go through the origin, right? Because if they go through the origin, then it's both, which is what this is about. When will a line have both an x and y-intercept at the same point? It's saying, does it always have to hit at 2 different points like this? No. It could be like this, right? Literally going through the origin, right? Which then hits 0, 0 for both, right? Okay, next. All right, so we want a line that's perpendicular. So line L is perpendicular to this thing. What does it mean to be perpendicular? Sure, right. So it means that they hit at 90 degrees, right? Let me explain why it's a negative reciprocal, okay? So I will do that by doing this. Is this thing even on? I don't know if it is. Oh, it is, I think, yeah. Awesome. So here's the idea. This is not a proof, but this is going to give you the intuition for why it is. So I have two lines that hit at 90 degrees. Here's 90 degrees, so 70, okay? All right. So let's find the slope of one of the lines. Let's do that by picking this point and having this be delta y and this be delta x. All right, cool. So there's delta x. We're going to say it's positive. I'm going to say delta y is negative. Are you cool with that? Mm-hmm. Now watch as I rotate that line 90 degrees. That'll rotate this L 90 degrees, won't it? Yeah. It will. So the blue here will rotate, and the pink will rotate. Are you seeing that? 90-degree rotation. Now, is this delta y anymore? Here it's delta y. No, what is it now? And is it positive or negative? Good. And is this delta x anymore? No, it's delta y, and it's positive. So what happened? The delta y and delta x switch spots, and the delta x and delta y switch spots. So originally we had negative delta y over delta x, but after we made it perpendicular, what happened? Well, after we perpendicularized it, we ended up with the same thing here, but changed, right? And now this is our delta y. So the pink and the blue switch spots. So in other words, they flipped and one got negated, right? So that's what happens. So if I have a slope of 2/3, after I perpendicularize it, it's going to be -3/2, or vice versa. Do you see how these two switch spots and one got negated? See how these two switch spots? No, it does not. Correct. So yeah, because if you think about it, you rotate this way and then that again, you're going to get like this opposite thing. Yeah, it totally works. So anyway, that's why perpendicular slope is opposite reciprocal. And this is the symbol I use for that, opposite reciprocal, right? Opposite meaning negative, reciprocal meaning flip in this case, right? So how is that helpful? Here's how. All right, hang on. We have to switch back. It takes a second. Be glad I didn't fix the sound this weekend because I was sick. Yeah, I know. It's doing all of the things at once. I don't know how to stop it. Thank you. Oh, boy. All right. So if this is the line we're comparing it to, isn't this kind of the slope of that line? So the line we want, line L, is going to have this for its standard form.
Okay. These are your
Oh,
extras.
thank you very much.
I
Thank
did
you.
write their names, but it's just in pencil. So you
All right.
can see your
Thank you.
extras.
Yeah, thanks. All right. Cool. Fam, do you see the connection? Opposite reciprocals, right? Because you could do the whole thing where you figure out the slope and then you find A and B and then you plug it back in, but that's going to be the end result, isn't it? Now, we got to figure out what goes here. Apparently, this line has the same x-intercept as this one. So what's this guy's x-intercept? X-intercepts are where it hits the x-axis. So what do all x-intercepts have in common? What do all x-intercepts have in common? They get hit on the x-axis. What do all of the points on the x-axis have in common, Kitson? Give me a point on the x-axis, Kitson. It has 0 for y, doesn't it? Right? They're not up or down, they're only left or right. So we know that y is 0, and then to find the x-intercept, we just have to figure out what x has to be. If y is 0, this is gone. What times 3 gets you 5? 0. You know y has to be 0, right? 5/3. So 5/3 is the x-intercept. This has the same x-intercept as this, apparently. Okay, cool. That means that 5/3 0 works in this equation, right? So let's plug that in. If you plug in 0, boom, gone. What happens when you plug in 5/3 to this? What do you get? Negative 10/3, right? So when we plug those in, we get negative 10/3. That's the number that needs to go here. There's your standard form. Although a meaner teacher would make you get rid of the fraction and unnegate this, but I'm not that person. So here's the idea. Here's our original line. Here's the perpendicularized version of it. They share this point, right? So if they both have that point, that means this point should work. So 5/3 and 0 should work in this equation. That's how I knew negative 10/3 needed to be there, so it would work in the equation. Ripley, you smell what I'm talking about? Smell what I'm saying? Yeah. What about you, Kitson? Yeah. So that's what's got to go there in order to make this point work. It's on the line. They said it was, so it better work. Nice. All right, 862 or no? Can I show you to do it really fast? Parallel, what does that mean? Same slope. I'm going to rearrange this so we can see it better in standard form. If I want a line that's parallel to that, what will it look like? It'll be the same thing, except it won't equal 8, because otherwise it'd be the same line. Hey, look, 3, 7 has to work, right? 3 minus 21. That's the line we're looking for. It's parallel to that. And it goes through 3, 7. Pretty slick, huh? If they're parallel, this has to be the same. 3, 7 works if this is negative 18. All right, any other questions? No, that was the last intermediate. All right, so we're going to 10 now? I heard 10. What are we doing for 10? Okay. Ten, 3, 1. All right, fun fact, this is actually intermediate. It just got moved on accident. Because when I convert files to PDF, it does that sometimes. Hi. Yes. So why are these intermediate? Because they have an a value that's greater than 1, right? We have a number in front of x squared. So how are we going to deal with that? Well, either it's going to be 10x and x for our factorization, or it's going to be 5x and 2x. Now, your entire goal is to try to eliminate as much guesswork as possible. Samantha, you better lock in. You are not thinking about this. So, we want to eliminate as much guesswork as possible. Do you see how it's either this or this?
It's the first one.
Now, stop. What goes here? Something that multiplies to 1, right? There's only one way to do it. Either positive 1 and positive 1 or negative 1 and negative 1. Which one do we need? If it's negative and a positive, it'll multiply to a negative. It's both negative. Now, the question is, which one of these is the one we want?
The first one.
Why the first one, Samantha?
Because you can't get 1 with 5 and 6.
Yeah, this will get us 10x squared, but so will this, right?
That's what I said in class the other day.
This will be negative 10x's. This will be negative 10x's. This will be negative 1x for a total of negative 11x's. And we get positive 1. So not this one. Don't forget, before they add, this is going to hit it. When we're doing basic stuff, there's never a number there, so we don't have to worry about that, right? But when there's a number there, it's going to hit this before they add together. Negative 10x's and negative 1x makes negative 11x's. So here's our factorization. Now, if Esteban were here right now, I would say, Esteban, stop forgetting to do this. You got to actually tell the answer. So when will this equal 0, Samantha?
When x equals 1.
Or?
Next x equals.
Nope.
What is 10?
Pause. You wish this was 1 minus 1, right? 1/10. Because timesing it by 10 gets 1, right? There are answers. There you go. 10's divide out, you get 1. All right. Down here, if we rearrange this to make it equal 0, we can actually solve it. So let's do that. It looks really scary with an 11 in the front, but it's not, because there's only one way to make 11 with nice numbers, and it's 11R and R. Don't forget, this is going to times whatever goes here by 11 before it adds up. So let's think. Do I need double positive, double negative, or one of each? Double negative. That way it multiplies to a positive, and it can add to a negative, right? So let's eliminate some guesswork. All we have to figure out now is what goes here. It's either 4 and 1 or 2 and 2. Is it 4 and 1 that we want, or 2 and 2? Where do I want the 4? It does matter. They're not symmetrical. By the 11. And here's why. If I put the 4 here, I'm going to get negative 44. I don't want that. This allows me to get negative 11 x's or 11 r's. And this gets me negative 4 r's for a total of negative 15. So now I answer the question, when will this equal 0? R equals 1, or what's the other one? Try again. Oh, no, you did great. 4 over 11, my bad. 11's divide out, you get 4 minus 4 is 0. Emily Kitson, are you doing okay? I can't come help you, but you can come up here and ask a quick question if you really need it. All right, Emily Kitson, discuss with your friends about this right now. Yes.
Okay.
My Kleenex box has been stolen. Well, the one that I had that was on my desk was stolen. All right, so Emily Kitson, did you discuss this with your friends? ASMR. Oh, I can feel it in my ears. No, I will in a second. Yes.
First.
No.
No.
It doesn't work that way. They have to have the same base.
That just like looks like that.
Here's
I don't know it.
yeah, you leave it like that, yeah. Okay. Emily Kitson left, huh? Okay. A lot of people think this one is unfactorable, but it's not unfactorable. It is factorable. What do you notice about all these? You wish they were divisible by 3, but they're not. Darn, so we're stuck with it. That's okay. We'll just use 3v and v. What else do we know for sure? What else do we know for sure before we move on? We need a positive and a negative. Because it'll multiply to a negative. Now, where do I want the negative? I'm guessing I want the negative here and the positive there. That way I get a big positive number, right? Yeah. And then subtract a little bit. So, multiples of 24, if you want to list them. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. So, now, which of these is going to work? Well, we need 3 times something to be kind of big to get to 34, right? And in relation to 3, 34 is pretty big, right? So maybe like 3 times 8 would get us 24, but then minus 3 brings us back down. No good. Ooh, 3 times 12 is 36, and then minus 2 is 34. We win. All right, so now we have to answer the question. Negative 12 and what? Yep. Yep. All right. Let's rearrange this. 15 is kind of scary. If we move that over, we do get 16 x's. They don't go away. All right, so now we have options. We can either do 15x and x, or we can do 5x and 3x. Here's why I think it's 5x and 3x. Do you see how this is going to times something by 15? Yeah. Now 16 is kind of a big number, but compared to 15, is it a big number? No. Timesing by 15 is going to make it much bigger than 16, right? If I have a 2 here, I'm already at 30. If I have a 3 here, I'm already at 45, right? So I probably want to use numbers that are smaller. So I'm going to go with 5 and 3. Now, could I be wrong? Yes. Now, only a couple ways to multiply to 4. Is it going to be double positive or double negative? Double positive. Be there in a second. So it's either 2 and 2 or 1 and 4. If I do 2 and 2, that's 10 and 6. That's a winner. I always try the ones that are 2 and 2, 3 and 3, 4 and 4 first because you don't have to flip them. It's very quick to. 10, 6, we win. 16. 16, don't forget, we added it over 16. So answers are going to be negative 2/5 and negative 2/3. All right, Casey, you have a question? Why are you watching this, Casey? All right. That's all of the basics. Are we doing the mediums now? You got to have 2 pieces of evidence, kiddo, so it really doesn't matter either way. What's up? We don't need to see anything on page 4? Samantha Kitson? Emily Kitson? Okay. Fam, stop making this more complex than it is. If I gave you this, would you distribute? Cool. So let's do that, and then we'll just times it by this. No, you did something else. I don't know what that was. X times x is x squared. All right, this is more advanced stuff, so I'm going to go faster. I get negative 5x and negative 2x for negative 7x. Are you guys following me? Yeah. And then positive 10? Yeah. All right, now I'm going to times everything by x and by 3, and then I'm done. I'll let you think about that for a second. Yes?
And I might do like that.
Yes, that becomes just 2. Right? 2 squared is 4?
Yeah.
4 divided by 2 is 2. All right, so after I times x to everything, I'm going to get x cubed. Hold on one second. Negative 7x squared plus 10x. That's timesing x to everything, right? And if I times 3 to everything, I get 3x squared minus 21x's plus 30. And then I'm going to combine like terms, and I'm going to do it carefully. These guys become negative 4x squared. These guys become negative 11x's. And just like you at the high school dance, 30 has no partner. X cubed has no partner. And that's okay. That's simplified. Now, we forgot one thing. What did we forget? When does this product equal 0? Can you tell where it equals 0 right now? Oh, we should factor it. If we factor that, we could do it, right? It's already factored. It's up here. So what are the answers? 2. 5, negative 3. Boom. Awesome. Yes. Yeah. You wrote what on what? What does that mean?
This is what you're currently doing.
Yeah.
This is what I was doing, and then I tried to follow along.
Oh, because that's the thing. Okay, that's okay.
So,
Yeah, so you're taking notes to study from, yes? Is that what's happening?
yeah, I was trying to do it on this one, and then you just.
That's fine. So,
Let's just like say that like I did it,
but it'd be wrong.
but it's okay because if I rewrite it on this one, then you say
You need 2 pieces of evidence, so even if you
But
do
I
one, it
have
won't
my-
matter.
I have my exercises.
Perhaps. Perhaps.
Perhaps.
Perhaps. Perhaps. Perhaps. The final will be the telltale. Fam. Okay. Do we do these or no? Emily? If we rearrange this, Emily, do you see how I'm not moving it over to the other side? I'm just rearranging it. What do you notice about all 3 of these numbers?
They divide by.
Yep, they do, and we can do it because it's an equation. This is going to be 18, I think. Yeah.
So I'm not going to be able to see the 243 divided by 3. That just doesn't work.
Well, how many times does 3 go into 240? 80. 24, 8 times 3, it's 81, yeah. That's because Ripley had me last year and you had me 2 years ago. Hello.
Right? Like, I'm right, understand, like,
No,
Or I-
19 over 5.
19 or... And,
Do you understand?
yeah, it will be 19 because that will be
Minus it, yeah.
plus.
Yeah. All right, now this is an easy problem. It's 9 and 9, isn't it? A perfect square. Only one answer, multiplicity 2. Are we done?
That's not all. 0, 0. No, it's times. Nope, that's wrong. Leave me alone. Yes, guys. No, because sometimes there's a problem with the x equals 0, and I don't really know which one that is.
That's if you have something like this, Samantha, I think is what you're talking about. X is 0, x is negative 9. All right, F or no? How would we make this better to work with? Multiply by 2 would be even easier. If I have 10 minus 1, that's the positive difference. 1 minus 10 would be the negative difference. Big minus small. All right. Are we good?
Okay, chapter 11, please.
No more 10? All right. How do we make this easier to work with? Yeah, we can do that because it's an equation, right? Because equations don't care if things get bigger as long as they're still equal. If I make everything 9 times bigger, it'll still be equal, right? So now I get 9t squared. What happens here? 9 divided by 3 is what? What's 9 divided by 3?
3.
Thank you. 3 times 2 is 6t. What's 9 divided by 9? Thank you. So we get 1 times 1, which is 1. Yeah, Reese, you should just like lock in next semester. That's my advice. If, I've always thought that about you. If you just locked in, there would be nothing stopping you, like nothing ever. They all other than that, yeah, it's unfortunate, but that's a hoop.
Why does the denominator, okay, when you have the 9 times the denominator of 3, why does the 3 go in the top?
So what I'm doing is this: 2/3 times 9. What this means is times by 2, divide by 3. It doesn't matter what order you do it in. So I'm doing 9 divided by 3 first. What's 9 divided by 3? 3. If I did this, this would divide out to a 1, just like this did. And this would divide out to a 3, and then I would get 2/3. This is going to be 2 divided by 1 times 3. 6. Do you see the difference? Here, 2 over 9 times 3. These divide out to 1 over 3, so it's going to be 2/3. Here, timesing by 9, these divide out to 3 over 1. Multiplication happens on top, division happens on the bottom. All right, so now we're back here. Which one do you think we're going to need? Probably this. Do you know why? Timesing by 9. Timesing by 9 is going to make things a lot bigger than 6, right? So it's probably not that one. There's only one way to make 1, so it's got to be plus 1 and plus 1. T is going to be negative 1/3, multiplicity of 2. It's a perfect square. All right. This right here, if we rearrange it, I'm going to move everything over by adding it, and minusing it. What do you notice about all 3 of these coefficients? They do divide by 3. We get 8z squared. This is 6 times 7. So 6 times 7 becomes 3 times 14. Are you seeing it? Are you seeing it? 6 times 7 becomes 3 times 14. So this is 14z. This is minus 15 equals 0. Now, 8 kind of sucks. There are lots of options for 8. We could have 8z and z equals 0. We could have 4z and 2z equals 0. The question is, which one do we want? Well, my guess is probably 4 and 2, because timesing by 8 is going to make things pretty big compared to 14, right? Like, just even if there was a 2 there, we get 16 already, right? So probably not that one, but I could be wrong. What do we know? What else do we know for sure? Yes, and I probably want the negative over here, so it's not getting hit by the big number, right? And I get a big positive number and then take away a little bit, right? Okay, cool. So 15, 5 and 3 probably. 15 1's probably going to be too extreme. So it's probably 5 and 3. If I put the 5 here, I get 20. Oh, I just win, right? Yeah, that's just how it goes sometimes. I'm not trying to get it right on the first try. I'm just using logic. So 5 and 3. 15 is going to make giant, right? So probably don't even want to try it. What's up? Uh-huh. You could, yeah, because then y would go away, yeah. All right, so this is our factorization, and then we get 3/4, and we get negative 5/2. All right, any other questions?
Can we do 11 intermediate?
10-5-1. Oh boy. Did you guys even bother watching the videos from the other day? It's like the same ones every day. Yeah. Well, what are you doing right now? Could be fast forwarding instead of waiting on me. All right. X minus 1 over x minus 2 equals x minus k over x minus 6. We want to find out
Yeah, it can be 6,
why can k not be 6.
because that would make the whole right side 1, and
This will never be
the
1.
left side will never be 1.
Any number you pick for x will never make this equal 1. They're always going to be separated, right? Yeah. So it can't be 6. Now we're going to find another one. Usually the strat everybody else uses, they just make up a number. Would not recommend that strat. Here's what we're going to do. We're going to get x equals a bunch of junk. And imagine I get a bunch of junk over k minus 7. If x is a number, right, if x exists, what can't k be? What can k not be? Why can k not be 7 here? Dividing by 0, x wouldn't be a real number, right? So what we need to do is get x on its own and find something like that, right? So to do that, what we're going to do is we're going to get rid of fractions by multiplying by x minus 6. Notice on one side it divides out because that's why I did it, right? That's the whole point. And I'm also going to multiply by x minus 2, and those will divide out. So what we're going to get is x minus 6 times x minus 1. And that's going to equal x minus k times x minus 2. And then we're going to distribute so we can get all our x's on one side. So x squared minus 7x plus 6 equals x squared minus 2x minus kx plus 2k. Everything with x, did I stutter? Everything with x is going to go to the left side. So that includes this guy. But it has k. It has x. So everything with x is going to the left side. If I subtract this over, hey, look, it's actually gone, isn't it? That's convenient. If I add this over, don't I get negative 5x's? And if I add this over, I get positive kx's.
Lift the chair up so that goes back.
Oh yeah, so I'm gonna be soon.
All right, focus. So I moved everything around so I have all my x's on one side. I moved everything over so I have all my x's on one side. Now, how do I get x on its own here? What's the big brain move? It's an Algebra 2 move. Algebra 1 student wouldn't get this, unless you're one of my Algebra 1 students, because we talk about it a little bit. The entire class of Algebra 2 can be summed up with this word. Factoring, thank you.
Yeah,
I have always believed in Reese, but Reese has to believe in Reese. All right. So now how to get x on its own. This is x times something. Hello. This is x times something, right? So how do I get this over there? How do I get this over there? Not subtract. This is x times something, right? If this was x times 6, you'd divide, right? So this is x times that. We got to divide. So we're going to get this divided by this. So what can k not be? K cannot be what? 5. Because it'll make x undefined, right? Those are the two numbers. Negative 6. Sorry, can't be 6, can't be 5. Ah. All right, 10, 5, 2, yes or no? Okay. That's all of the intermediates. Ah. Do we want to see quiz 4 or quiz 11? Or 5? Okay, 11. All right, 11, what are we doing? 11.3.1. All right, this is the hardest part of chapter 11. It's the cubes, right? So, let's factor it.
I don't like roots.
All right, this is a difference of cubes. Don't be a weenie like they are. That's why they're bad at it.
This is not the right. Why do I have a different quiz than you?
Do I have a different one? Did I give you that one?
I have a different one.
All right, well, maybe I didn't give you that one, Samantha, or maybe I gave you a different one. So this is quiz 11, right? Yes.
10.3.1? 11.3.1.
He's on page 2 like the rest of us, not page 6.
Okay, so I'm right, she's wrong.
No, I want 11.3.1 intermediate.
Got it, okay.
Sorry. I didn't know there was more than one.
All right. So the reason this is hard is because it doesn't look like it's a perfect difference of cubes, right? The 6 is a cube. Z cubed is cubed, but 2 and 16 aren't. What can we factor out? Do you notice? What else? If we do that, we get 1 minus 8 z cubed. And what's left over is a difference of cubes. I don't have any left right now, I don't think. Wait, hold on. I have, I think. Hold on.
Well, not for quiz, just so I can write this
Oh, to follow along?
down. Yeah.
Then I really don't have one. I can print them out though. Hold on. Wait, hold on. Maybe I'm wrong. Maybe I'm wrong. Alright, I'm gonna print out some quiz 11s for Casey, and then Reese, do you also need a quiz 11 to follow along?
Yes.
I thought I didn't throw them at you.
You gave me, I have 8, 5, 4, and I have 3.
But not 11s? Okay, I will print some, oh, maybe I did. I think I did. Let me go grab them.
I found one on the door.
That's what I was debating. Do I sew it back on or do I just cut my off?
difference in my mind. That's true. Sometimes that's not what's required. All right, Samantha, let's factor this. This is a difference of cubes. This is 1 cubed, right? 1 and 1. 2 and 4. Z and Z squared. Are you with me? This gets us 1. This is this guy squared. That's that guy squared, right? 1, 1 squared. This squared. What? That's what I'm looking at right now? At all?
Are you on mild or page 6?
Okay, good. All right. Sam made the same mistake. It's all right. All right, so.
You made the mistake, not me.
I know what you mean. Yeah, no, I understand your perspective. All right, and so in the middle, we're going to get plus 2z times 1, which is this. You didn't specify, but yes, I should have been on the page that you wanted. Yes. Because she didn't specify. So she didn't make a mistake. She just didn't specify.
It's good that I'm strong and I can I feel like Macy up in the today.
All right, so part D.
Yeah.
This one's weird. Do you know why it's weird?
You're negative.
Yeah, what if we factor out the negative from everything? Turns out this is actually a sum of cubes in disguise.
Can you factor out a 3? The cube 3?
No.
No, because
No, it's not dumb, but you just can't do it.
Ow. Wait, you can do like. Whoa. What are you doing?
Whoops, I need a minus sign. So, Samantha, see how this is a cube? So I need 1 there, and then I need the square there. See how that's a cube? I need 1 there, I need the square there.
Can you do the right side again?
The what? No.
That is not.
So, again, the reason why this works, guys, is that this and this gets us back to that, right? This and this gets us back to that,
Why
yes?
can't you do like negative out there and then you have like A, B in parentheses and then the 3 on the outside and then the
You definitely can.
so that way.
So, are you saying that this right there, that part right here, is the same thing as this? Yes, I agree it is.
So why can't you
So you could definitely do this here. Yeah.
okay.
Make you feel better? But you can't do this. That's different.
Alright. 'Cause that's just A.
Yeah.
And then there isn't.
Now, notice that this creates problems. We get 4ab, right? Let's see how this takes care of it. Negative 2a or negative 4ab. See how we have a problem here? 2a squared b squared. That's not anywhere, right? But look, this takes care of it. Negative 2a squared b squared. That's why that middle part's super important. It gets rid of all this stuff. Well, it's always these guys multiplied, but you can also just think, right? So see how I'm going to get here? I'm going to get 2a squared b squared. So what do I put here that's going to make this negative 2a squared b squared? 2ab, right? That's the idea. All right, 1133, yes or no? All right, we're going to get 4 factors, it says. Everybody stops at 2. So this is both a difference of cubes and a difference of squares. Do you see it? Let's use difference of squares first because it's easiest to understand. This is x cubed squared minus what number squared? So if I factor it, I'm going to get x cubed minus 8 times x cubed plus 8. Are you seeing it? right? Middles go away, you get x to the 6, you get negative 64. Now we're not done, because what are these two? What is this? What is it called? It's a difference of cubes. And that's a what? A sum of cubes. So we can factor it again. This first one's going to factor to x minus 2 times x squared, and with a plus 4. And what's going to go in the middle, Samantha? Mm-hmm. And this other one is going to factor to x plus 2. This other one's going to factor to x plus 2 times x squared plus 4 minus 2x. So there's our 4 factors. Yes. 6th powers can factor to a difference of squares and then a difference of cubes. That's kind of cool. Remember, no notes on the final. So if you're like, I'm just going to copy this down and use the notes, that's not going to work.
I'm writing after.
Okay, I just want to make sure we're actually following. Then whatever you turned in for chapter 11 will be your grade. Right? Does that make sense? Right? Because it can't hurt you, but it won't help you because you didn't do it. So, I don't know. Up to you. That's a little tough. A little tough. Why do you put yourself in these situations where you rely on the final? I don't know. Why did I advise you to do that? Why did I tell all my students not to do any of their homework or any of their work for the first 15 weeks? I should have told them to do it. Why did I? So dumb. So dumb, Mr. Mack. Oh, my God. I should have. This is on me. All right. Now what? All right. Here's the big brain play. This right here, I wish we could just cube everything individually, because if you cube those things, they go away, right? Check it out. I'm going to just write something down. This is the sum of cubes, right? Can you see it? Yeah? Well, we're summing, it's adding. And aren't these cubes? That's it? Sum of cubes? Because this factors really nicely. It always factors to this pattern. Right? That gets us our cubes, right? But there's a problem, Samantha, right? Aren't we going to get AB squared? So I need something here that gets me, yep, negative AB squared, right? And yada, 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 right? It gets rid of all the other extra crap. Okay, cool. Check this out. Do you see how this right here is, I think this will work. This right here is this. Do you see it? If we times it by this, then we get back to this, right? So if this is a squared, what's a? If that's a squared, what's a? If this is a squared, what is a? If this is b squared, what is b? Do you see if we square that, we get cube root 9? Roots are not scary. You guys overthink them. They work like regular numbers. It's not scary. If you square this, you get cube root 9. Now, do you see how this together is AB? I told you this and this are the same thing. So if we take this and times it by this, we get back to this. So what is A? 3. What is B? Cube root of 3. That's what we're going to times by. Because when you times this by this, we know you get this, and it's going to cube everything. It's going to get rid of all the cube roots. So when you take something that looks like this and times it by this, you get this, right? Yeah. And that cubes everything. It takes all your A's and B's and cubes them, essentially. Why is that good? Because cubing all this will get rid of the roots. So this part is this. What? Because cube rooting and cubes are inverse operations, like addition and subtraction, multiplication and division. Also, cubing something means you times it by itself 3 times, and cube roots are asking, what do you times by itself 3 times to get it? So they undo each other, essentially, is the shorthand of that. So in other words, if we take this thing and times it by that, we win. So here's this thing. What's this thing? It's these guys. Now, you could distribute and get 27 and yada, 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 but you know what's going to happen when you times these together. You're going to get this, right? So in the bottom, we're going to get a cubed, that's 27. And we're going to get this cube, that's 3. Mm-hmm. I'll do it again. We know when we times this by this, we get this, right? Yeah. We know that's the pattern it'll solve. Now, I could distribute 27, I get this thing, it goes away eventually, right? But that's the shorthand of it. Yeah. So the bottom is going to be 30, and the top, since it's 4 times this, will be 12 plus 4 cube root of 3. And then just to make sure you don't get it wrong, what common factor do both these share? Oh, wait, hold on. Never mind. I was going to say, yes, 4, but let's take out a 2. Why a 2? So that this can factor, and they divide out. So 6 plus 2 cube root of 3, all over 15 is our answer. So,
You have the 4 and the 12. Just like you multiplied it and then you put the 4 in.
4 times the 3 is 12. 4 times this is that. See how they're separate terms? Do you see how they're separate terms here? There's 2 terms.
Yeah.
4 times 3, 4 times this. This one's tough. If you had like, a week to digest it, I think it would be totally doable, but that was 4 weeks ago or something, and no one paid attention, so there's that. Yeah. That is correct. No. I mean, I'm going to scan it and then upload it to you or Classroom. Yeah. That's a 15. That's 15. All right. If I gave you something that looked like this, like let's say this was 8 plus root 7, what would the conjugate be? I'll say it again because no one's paying attention. Thank you. See, if Reese locks in, she's fine. So we would do something minus root 7, right? That would be the conjugate and we'd win. So here's what I'm doing. I'm basically saying, isn't this just one number? Right, root 2 is something, you subtract root 5, that's going to be a number, right? So just treat that like it's one number, and then we'll make the conjugate minus root 7. So it's going to be negative, or sorry, it's going to be root 2 minus root 5 minus root 7. Root 2 minus root 5 minus root 7. You actually don't change both signs. And again, here's why. Think of this as some number, okay? It's going to come out to something, right? Wouldn't we just change this guy? Something plus root 7, we would change that sign to make the conjugate, right? That's the idea. We're treating this as if it's one idea. Yeah, let this be x, yeah. So that's why you only change one of the signs. Everybody gets goofed because they think they got to change all of them or something, right? So what do we get? Well, when we do this, the top is going to be 2 times all of that. Ain't nobody got time to distribute.
Does it still work if you do the root 2 plus 5 plus root 7?
No, because it's not the conjugate then. You've changed this number. Root 2 plus root 5 is not the same thing as this. So let me show you what I mean. Okay? Let me show you what I mean. What is the conjugate here? 1 minus root 5, right? If I made this negative, is that the conjugate? Hello? No, you just changed the whole thing, right?
No, but if you put -1 plus root 5.
That could work.
That's what I'm saying for the other one.
Yeah, but you didn't change both then.
Yeah, I did.
No, hold on. See how these are conjugates? Yes, that works. But did you change bofa? We changed bofa here. This works, this does not.
Go back.
I'm going back.
So why
If you change, so
root 2 plus root 5 plus root 7?
yes.
That's what I said.
Oh, I get what you're saying. So you keep that one and then you change this one. That will work, yes. In that case, yes. Sorry. All right, so what do we get? Top becomes all that times that. I'm not going to distribute. I'm lazy. Root 2 times root 2 is 2. Root 2 times negative root 5 is negative root 10. Root 2 times this is going to be negative root 14. That was root 2 going to everything, right? We cool? All right, negative root 5 to everything. We get negative root 10. And it's kind of scary that they don't go away, but that's okay because one of them's not going to go away. That's okay. Negative root 5 times negative root 5 is positive 5. Negative root 5 times negative root 7 is negative root 35. And I'm running out of room. That was root 5 to everything. Negative root 5 to everything. Root 7 to everything. I'm just going to do this. Plus root 14. Minus root 35. Minus 7. Now, everything except one root should go away. Maybe a number, like a regular number, will be left over as well, okay? It's going to look like a basic problem when you're done. So in this case, it's really convenient, but rare that that all goes away too, doesn't it? Yeah, that usually doesn't happen. Usually have a number left over. All of these go away. Whoops, did I miss something? Negative root 35. Yeah, this one should be positive. This one should be positive. Root 35, this one and this one is going to be positive. But these go away. These go away. So what are we left with? We're going to be left with negative root 10 minus root 10, which is negative 2 root 10. So let me show you what that becomes. We're going to get this. Right, 2 of them. Negative what? Because that's not how roots work. Think of this as, I know, because you noped out on section 7 and section 8 of Algebra 1, chapter 1. Yep. I know. So think of this as x. Isn't this negative x? Think of it as x. Negative x minus x. Negative 2x, right? That's how that works. Okay? All right. Notice that this divides out, and we get root 2 minus root 5 minus, I know, and so this becomes negative root 10. All right, but we're not done. See how it still has a root in the bottom? Do you know what we can do to get rid of that? It's pretty simple. You just times by root 10, because that'll become root 100, right? And what is the root of 100? Root of 100 is 10, yep, and it becomes negative 10 because there's a minus sign on the outside. And then we just get this. Root of 20 minus the root of 50 minus the root of 70.
Wait, that's what the minus sign.
Yes, yeah, timesing is the difference, right? Yeah, now you're getting it. Yeah, that's good. You can times roots together if they're the same roots. Yeah, they're all square roots, so it works. But you can't subtract them like that. All right, cool, there we go. There it is. Again, what we're doing right now is the stuff you need to do to get an A. You need to have like 2 pieces of evidence for all of this, be able to do it on the final more or less, right? That's what's required. If you did all the homework as well, you'll barely get an A. I think it'll come out to like a 91% or something. If you do that on every quiz. If you do some of the advanced stuff to go along with that, that's going to help with it a lot, right?
Can you go back to the mile?
No. I just do 3 more problems and then I'm leaving.
Do you want to know how to do 11.5.3?
Yes.
You don't.
11.5.4. Wait, why don't we need that?
Because what they're trying to get you to notice is this has a factor of 13, this has a factor of 13. This has a factor of 19, this has a factor of 19. This has a factor of 7, this has a factor of 7. But everybody's just going to do it left to right, and you'll get your answer a lot faster. It was a thing you did in the homework, in theory, to help you see a combination and something cool. But I put it on there because my rule is I put everything from the homework on this, right? But the way, it's much easier to get an answer by just going left to right. But you won't see the point. So what's the point? I don't care. The further the year goes on, the more lenient I am. You know that, right? Like at the beginning, I want exact, that way it pushes you to be better, right? Because I want to make you guys better. That's the whole point of this, right? But towards the end, after the final's done. There's no getting better. So why should I push you? Right? I need to hold you accountable, but I shouldn't be like, ooh, they missed one little thing. Man, do they know it? Or yes or no is the ultimate question. I do things for your benefit. It will turn out better than you think. Anybody else that did any other type of grading with this, your grade would be much lower. I promise you this, okay? It is if first semester you actually learn stuff. So, all right. actually learned it, not just memorized it for a test, or worse, made up random things by moving things back and forth, right, between notes and quiz. All right, and I tried to warn you against that, but nobody actually listens. So anyway, this one right here, it says, how many different ways can we make 1/6? So here's a fun little question that someone might come up with, right? If I'm only allowed to use fractions that look like this, 1 over something, right? How many different ways can I add to 1/6? That's kind of a fun question. Now, here are the rules. They have to be distinct. So you can't be like, oh, 1/12 plus 1/12, but also 1/12 plus 1/12. That's 2 ways. No, because flipping that doesn't change anything. Do you know what I mean by that? Right? We're going to count that as 1 way, not 2 ways. They need to be positive. If I make this a negative fraction, then we have a lot more possible answers, right? We could go below -1/6, then add back up. That's going to be annoying. So, in other words, we have this rule. M and N have to exist in the positive integers. So we're only using positive whole numbers. You're not using like weird numbers like roots and stuff. Like we're just keeping it simple. And also, this cannot be true. We don't want them to be the same number, otherwise it's irrelevant. Well, it depends on how you interpret it. I'm going to go with my whole can't be a 12th and a 12th, also a 12th and a 12th. We're not going to count that twice. Cool? Cool? Okay, all right. Depending on how you read the directions, you might think what I wrote down, and that's not what they're getting at, but I'll give it to you either way. All right, so how do we solve a problem like this? This is a tough problem. What if we could turn this into a problem we have seen before? Why is this problem weird? What's weird about it? It's not 2 variables. We solve problems with 2 variables all the time. It's fractions. Yeah. So what can we do to get rid of fractions? It's an equation, so we can multiply everything. Even though everything's going to get bigger when we multiply it, it'll still be equal, so who cares? So I'm going to times this by 6m and n. Why? It gets rid of the bottom. It's the smallest thing I can think of that's going to get rid of 6m and n. Now, it's not going to get rid of all of them everywhere, but it's going to get rid of all of the ones we need to. Here's what I mean by that. N's divide out here, right? What's 6m times 1? 6m. Right? M's divide out here. We get plus 6n. 6 divides out here. We get 1 times mn, which is this. Now, that looks a little bit better. Now, check this out. If I write this on the left side and subtract everything over, now I get this. And this looks like something we know how to factor. And now we're asking, how do I multiply to 0, right? That's a much easier question, but apparently it's the same thing as this. We need m and n and -6 and -6. Now there's a problem. This is not that. Kind of. Yes. No, you're right. You're right. What? Because m times -6 gets us this. And -6 times n gets us that. Good question. But we also have 36, don't we? Oh no, there's no 36 here. You want to know what I can do to fix that? Ripley's idea. Let's just add 36 to both sides. So now we're not multiplying to 0, which kind of sucks. We're multiplying to 36. But we can still figure that out because we know we're only using whole numbers. So Samantha, here's our job. We need to think this times this gets 36. What 2 numbers multiply to 36? Give me 2 numbers. 6 and 6, right? Okay. What would m have to be? Let's make a chart. What would m have to be so that it comes out 6? What minus 6 gets you 6? So 12 and 12, right? I told you a 12th plus a 12th is a 6th. Okay, so we found one. Give me another way to multiply to 36. Yeah. What would m have to be to come out to 1? Yeah. What would n have to be to come out to 36? Did you know that a 7th plus a 42nd comes out to 1/6? You do now. All right, let's keep going. What if we had, because that's what it's asking. How many ways can you add to a 6th? All right, what else? 2 times 18, right? All right, so that's going to be 8, and that's going to be 24. 1/8 plus 1/24 is a 6th. All right, so we've done 1, we've done 2. 3 times 12, right? So now we've got 9 and 18. 1/9 plus 1/18 is 1/6. We can do 4 and 9. That's 10. And then 15. 1/10 plus 1/15 is 1/6. 5, no. 6, yes, but we already got it. We're done. Here are all the ways to do it. 1/12 and 1/12, 1/7 and 1/42, 1/8 and 1/24, yada, yada, yada. 1, 2, 3, 4, 5 ways to do it. How you feel? What if I told you the next problem is basically the same thing? Yes. That's fine. Yeah, that's fine. All right. So, Samantha, isn't this like pretty much factorable, but it isn't? Oops. There's a chair there. It would factor to P, -3 here, and 5 here, right? However, this isn't really this, is it? What's it missing? Got it. Got it. Got it. We got -15. So what if I put -15 here? In order to do that, I have to do this. So in other words, we're trying to find numbers that multiply to -15. So this is going to be -1 and 15. It's going to be 1 and -15. It's going to be 3 and -5. It's going to be -3 and 5. It's going to be, oh, and I forgot about this. It's going to be 15 and -1. It's going to be -15 and 1. So it's going to be these guys flipped as well, right? Because it will matter. These aren't symmetrical like the last ones were. So we got to list all of them, right? So I'm missing the 3s and 5s. So what if this was 5 and -5 and this was -3 and 3? All right. So now we got to find all the numbers that work. Let's do that. P, Q. P would be -6. Q would be 18. P would be -4. Q would be -12, and on and on and on. Does that make sense? Okay. Find them all. I think that's it for the intermediates. It is. All right, basic for this one? All right, 11 basic. All of them or no? All right, what does it mean to square something? Do you know the most common mistake on this first one? Everybody tells me it's this. Why are they wrong? You don't distribute squares. If you write it out, you won't make this mistake. They're kind of right. I mean, we are going to get x times x, which is x squared, right? We are going to get positive 25, but what are we going to get in the middle? Minus 5x and another minus 5x. They forgot their linear term. So it's going to be x squared minus 10x plus 25. Are you with me on that? Not this. How are we feeling about that? Okay, now what do you notice about the next one? Yeah, so the only thing that's going to change, we're going to get x squared, we're going to get 25, but now we're going to get two positive 5s in the middle. It's going to be this, isn't it? Notice that perfect squares always have square and double. This is a perfect square. It's always going to have square. And it's going to have double whatever this is. It's going to be positive, sorry, not positive, negative 42y. Now I'm going to prove it to you. Let me prove to you why this is the case. This will become 9y squared minus 21y minus 21y. Do you see how it's this guy doubled, 21 doubled, right? 21 doubled. And we're going to get positive 49, which is this. All right, quickly, do it in your head. What's the next one? Mm-mm. 9y squared plus. It's the same thing as the one above, right? It's just that we're not going to get any negatives in the middle. We're going to get positives in the middle. Right? With the negatives in the middle, you get these guys, right? Negative 21, negative 21y, right? But the outside still be positive, either way. All right. You can tell these are perfect squares because we have perfect squares on the outside and double 3 and 7 in the middle. All right. Down here. Is this a perfect square? Do we have the same thing twice? Well, if we did, it would be z and z. What number would have to go here and here? Has to be the same number. What number? Good guess. 2 and 2. Is it going to be positive or negative? Has to be the same. If it's double negative, will it come out to a positive 4 or negative 4? It's not a perfect square. Not possible. No. Not possible. Could it be factorable? Sure, but it's not. But it's not a square, right? Can't be. This one could be. What would it be if you had to guess? Won't that get us 5 times 5? Yeah. And it'll get us 5r and 5r for 10r. Yeah, works. It's a perfect square. What about this one? $20 times 20 doesn't get you 400. But even if it did, it wouldn't get you 20. Here, it'd get you 40, right? So no. Well, $20 times 20 does get you 400. I don't know why it said that. Yeah, I knew that. So 20 times 20 does get you 400. So it would have to be like this. It would have to be this, right? However, what's the problem? It doesn't get you, it'd be 40 in the middle, right? Thank you. Good. Okay, awesome. Sorry. I knew I was misspeaking. I just couldn't remember what I said that I misspoke. All right. All right. What about these ones? What are these? What do we call them? Difference of squares. Reese. Okay, so this will be factoring to conjugates because there's no middle. We get T and T, dynamite. What's going to go here and here, you think? Both positive, both negative, what? Yeah, that way we get T squared minus 7T plus 7T goes away, and we get minus 49. Yay, you factored it. All right, this one. Don't freak out just because the variable's second. Everybody does that. What do you think goes here and here? Here and here. Here and here. Thank you. Everybody tries to like flip them and then they do it wrong. Like just don't touch it. All right. We definitely need X and X. We definitely need 3 and 3. But that will come out to positive 9. So we definitely need this, right? Plus minus. Doesn't matter which order you do it in. You did it. It's conjugates. All right. This one that we almost did earlier, but that we actually didn't. What is this? Is this a difference of squares? It's a difference of cubes. What number do you cube to get 1,000? 10. So we definitely need x squared here. And we definitely need 10 squared here. That's 100, right? See how it's going to get back to 1,000 now? It's always this guy squared and that guy squared. It has to be, right? That's how you get back to cubes. But there's a problem. Do you see how this gets us 100 x's? I don't see 100 x's. So whatever goes here is going to have to get rid of it. What times negative 10 gets you negative 100 x's? Thank you. Do you see how that gets negative 100 x's? Minus 100 x's minus 100 x's is gone, right? This also solves our other problem. Do you see how here we have negative 10x squared? I don't see that. But do you see how this takes care of it? Positive 10x squared? Awesome. So we get everything we need. Hooray for that really nice factorization. All right, over here. This is also a cube problem. It's a sum of cubes. All right, what number cubed gets you 27? And r gets you r cubed, right? What number cubed gets you 64? And it's a sum of cubes, so plus sign. I'm going to write 9r squared here to get back to 27r cubed. And I'm going to write plus 16 to get back to 64. What goes in the middle? Definitely a minus sign. Here, let's deduce it. Do you see how, let's do this one. Do you see how this gets us 36r squared? Don't like that. How do I make negative 36r squared? 12r. Did you notice that it's these guys multiplied together every time? Turns out that's the secret. These two multiplied together is always what goes in the middle. It's kind of sick, right? And it does take care of both of our problems. This is another problem. That's going to be 48 r, and this is negative 48 r's, right? We factored it correctly. If you had a week to digest, we'd feel really good about this. But we don't, because I famously did not teach anything for 15 weeks, and I told you no homework, no practice, just party. And then now I'm demanding you to know this stuff. Why did I do that? Why? Stupid. All right. I shouldn't have wasted 15 weeks. Why did I do that? All right. 11.32. Yes or no? Okay. What is this? It's a sum of cubes. All right. So what are we cubing then? What are the cubes? 3 squared cubed and 2 cubed cubed, right? What is 3 squared? So it's really 9 cubed. And what is 2 cubed? Yes. So what we want to do is factor this. Okay, we can do that. I don't want to do 9 cubed. I don't want to do 8 cubed and add them up and then try to factor that. That sounds awful. So how do we factor it? Well, it's going to be 9 plus 8 times 9 squared plus 8 squared. And what goes in the middle? Minus. Do you see it? We have 9 times 8 times 8. I need this to be negative 9 times 8 times 8. So I need negative 9 times 8 here. I'll get rid of it. 9 and 2 eighths. 9 and 2 eighths. 9 and 2 eighths. Minus 9 and 2 eighths. It's these guys in the middle. It's those two again. All right, let's simplify this. 9 plus 8 is 17, right? What is 9 times 9 minus 9 times 8? It's 9. Do you know why? 9 nines minus 8 nines. Pause. 9 nines minus 8 nines is 1 9, right? So we have 9 plus 64. What's 9 plus 64? 73. Hey, look, that's the prime factorization. So this really big number, whatever 17 times 73 is, if you had added those up, you would have had to figure out, oh, it's divisible by 17. There's no other numbers that divide it, right? And so that's really hard to do, but this reveals it, which is kind of nice. Emily Kitson on her phone. Her mom doesn't let her on Instagram or YouTube Shorts even, so she has to go on Google search images. She goes onto Google search images and she just like Googles like happy people and she's like, oh, I love it. Yeah. Oh, look, here's all my people. Yep. She just Googles Esteban. She's like, ooh. You gotta do it. To be fair. Yes. And then you'll email it to me. And that'll give you more time. Wait, hold on. I need to grade that first. So I will grade it. And I'll give it to you tomorrow. Or whenever, because you gotta, yeah, you send me the file, right? The folder, you know what I'm talking about? Good. Yes? Sure. Why not? Why not? Why not? Why not? I'll take it. That's because you made bad choices. However, I work really hard to make sure that your life skills have very little, if anything, to do with your actual math grade. But it takes a while for me to do that because I have to kick your butt and make sure you get stuff done, and we have to wait till the last minute to change your grade, and parents hate that, but I do it because it's good for you. Mm-hmm. Yeah. The real problem, if people were smart, is they would realize it's you, not me. But people aren't smart, so people think that I just don't plug in grades, like I just don't ever grade. That's what they think, which is funny because I grade like every night, and I'm like, please get me your stuff. If I was like, that's it, the grade's permanent, then people would be like, wow, he's so fast at grading, and then they'd be like, why is my kid failing? And I'd be like, because your kid's dumb. But they don't like to hear that either. All right, so anyway. So I do what's best for everybody except for me, and you learn, and your parents are happy, and I survive, and it's life. All right, cool. So this thing right here, how do we get rid of the radical in the bottom? Yeah, root 6 times root 6 gets rid of it, doesn't it? Now, why are we allowed to do this? Why are we allowed to times by root 6 over root 6? Yeah. So timesing by 1 won't change the number. It'll just make it look different. Notice it's still going to be a weird number, right? The top's still going to have a weird root. We can't get around that. The number's weird. If it's not weird, then you changed it, and we're not trying to do that. So what we get in the bottom is root 36, and what is the root of 36? All right, so we can simplify that, right? What is 3 over 6? 1 over 2, right? Yep, root 6 over 2. So all we're trying to do is just make this not have a root in the bottom. Turns out root 6 divided by 2 is the same thing as this. People like this better. I don't know. All right, now here's the danger. If you do the same logic over here without really thinking about what's happening, you will get it wrong. I know, it gets them every time. All right, why does this not work? This is what we would get if we did this. Square root, yeah, if you fifth root a square, it doesn't get you back to the original number, right? It needs to be fifth root a fifth, right? We need that to be a 5. So this is what we'll do. And now it'll work, right? Because 9 times 9 to the 4th is 9 to the 5th, and what's the fifth root of that? 9, right? So this becomes 9. What is 9 to the 4th? I don't care. It's 81 times 81. Ooh, that's not that bad. 640 plus 160, 6561, something like that. No. Yeah, 6561. That's okay. We're not going to do it. So yeah, you need the root to match the power. Otherwise, you won't get back to a nice number. See how this is 6 squared? And when you square root a square, you get back to the original? Ripley, are you believing this or no? It all goes back to chapter 1, section 7 and section 8, where you guys are like, I'm just not going to do roots. It'll be fine. There's that same mentality you just had there. That was crazy. Wow. I have good news for you. Turns out, you know, you can like factor quadratic equations, and there's like always a way to solve them. Cubics, yes, there's a formula for that as well. And there's a formula for quintics up to 5. No, there is no formula for quintics, so you only have to go up to 4s. After that, it's all just using your brain. Yeah, I know it's bad news, isn't it? All right, so down here, multiplying by the conjugate, right? I ruined this because I didn't think we were going to go back to it. Do we need to see this or no? Okay. See how I'm timesing by 1? It won't change anything. But now I'm going to get 1 times 1, which is 1. And I'm going to get negative root 5. That's bad. Except, not only am I going to get negative root 5, aren't I also going to get positive root 5? That's 0. It goes away. And then root 5 times negative root 5 is negative 5. Hey, look. That's going to be a nice number in the bottom. It's negative 4. In the top, we get 2 times negative 2 root 5. So 2 minus 2 root 5. Now, fam, what common factor does the chop share? 2 over 4 becomes a half, right? So we get 1 minus root 5 over negative 2. Because that was negative on the bottom. Okay, what's the conjugate over here, Emily Kitson? What is it? Say it. Yep. You could distribute everything and write it all out, or you could just think, what's 3 times 3? Yeah, I knew Reese was going to answer that. 3 times 3 is 9. Fam, this becomes 6 root 7, right? Nice. This is minus 6 root 7. So it goes away, right? And then this will become negative 4 root 49. What's negative 4 times the root of 49? Negative 4 times 7, right? What's negative 4 times 7? It's this guy squared and it's that guy squared. What do you know, right? Difference of squares. Conjugates always go to a difference of squares. 3 squared and this squared. If you square this, you get 4 and 7. 28. The top will be 3 root 7 plus 2 root 7 times root 7. So that's 2 times 7, which is 14. If we simplify, we get this. All over negative 19. Chapter 11 quiz to take, to do. I can get you a chapter 11 quiz. I have to print it. No. I can give you a chapter 11. Is this all we needed to see? There's 2 more, but they're really easy. You could do this without me even teaching it, probably. Bripley. Imagine you had to factor this. How would you factor it? Take a wild guess. You can be wrong. Be wrong. That's how you learn. We'll go here. What would have to go here, you think? Plus what? Well, if the 2's there, the A won't hit it. So you want the 5 there so the B does, and the 2 here. Hey, look, isn't 5 times 2 10? You did it. Do the next one on your own, Emily. Walk away. Binley? That's crazy. Oh, no. So you're bad at basketball, and that's what the coach calls you? Oh, no. Yikes. 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 Okay, cool. So what's this one? Well, whatever goes here, the x is going to multiply with it, right? That's a good idea. I'm always encouraging that. Yes. 8x, negative 3y, negative 24, xy. Boom, got it. Yeah. If you don't have to think about it, it's a waste of time. Might as well just skip it. Give you a word search.
Here. Oh, my name's on it. Am I allowed to print this here or pride not?
Prob's not. You should keep it and do well in the final tomorrow. Remember, the final counts as double if you get stuff right on there, so you guys should just knock it out of the park in the final tomorrow. What is this? Thank you. All right, so we need 11, ladies. Is that what I'm hearing? Ripley, are we done? Oh, we want to do, wait, didn't we already do intermediate? Oh, we did not. We did a couple. All right. So the ladies back there have requested to take a quiz 11. Oh, wait, who? I said ladies, so who was I not including? All right, stop. Who would like a quiz 11 to take right now? Okay, is that everybody? So how am I going to do this while you're doing that? Okay, so if I print them all now and give those two theirs, and then we work on this, yes?
Yeah.
Okay, cool. All right. I will be back at quiz 11s. Okay, I gotta make sure it's not the same thing as this. Minus 5. That's the same one. This is not the same one. I wonder if anybody's gonna be here in 40 minutes. Because if not, then I can go home and sleep and then I can grade. That would be nice. Christina, go home. Go home.
Esteban just comes over and flirt on me. Like, that was not cool.
Well, he's trying to put it on Dom, and then
Yeah, don't mind him. And then he's like, she's this person. She's right there. You can ask her. You don't have to stop her. I'll be right there. Oh, really?
Hello?
Hey there.
Christina, do you understand? Okay. I think you should just relax. Unless you're having fun. I know you do enjoy math, but you don't need to do every question. It's okay. It's not expected.
I know you like, just one or two, like, questions with words.
Okay?
That is what, why I want to do like, where they like that question. Because like, I'm not doing that, but.
Yeah, that's fine.
If I do this like 6 times,
All right. Ripley, it's just you and me. This one? This one? All right, so this is basically saying, if I have a plus b squared, do you see how this is a plus b squared? This object, right? The area should add up to these pieces. How can we prove that using this diagram? What's the area of this square? Mm-hmm. What's the area of this square? What's the area of this rectangle?
I don't know.
What's the area of the rectangle? A by B. And so is this one, isn't it? Two of them. Two ABs. So the area is just these pieces put together. That's kind of crazy, huh? What do you know? You can do the same thing with a difference of cubes or a sum of cubes by extending it back like this and having it be like A here and B, oh boy. You get the idea, right? And so that will also get you this formula if you figure that out. Kind of crazy. All right. Ah, you got these. Come on. How are we going to think about this? Yeah, that's why I said you've got it. Okay, cool. So we're skipping it? Okay, awesome. That sounds great. What is this? Do you know what 11 squared is? This is the difference of squares. Problem, this doesn't look like a difference of squares. 800 is not a square number. So what do? It's a difference of squares in disguise, actually. What common factor do 872 share? 109. Those are squares, right? So I'm actually going to take out x squared as well, just because it'll make it easier. And we'll end up with this. And then I'm going to see if you can factor this while I help Christina. Say it again. 90 times 23. 1,000 and 270. Yeah, 207. Yeah.
All right, sir.
Thank you. All right, Ripley, 10x plus 3y, 10x minus 3y, right? Oh boy, you ready for this next one? All right, we want to figure this out. Isn't this the same thing as this? What we were doing, yeah. Mm-hmm. Except this isn't a nice thing to calculate, right? So good thing they gave us it, right? Hey, guess what? We're gonna get 5, 5, 5, 5, 5 twice. Let's add that in our heads, so we don't have to write it. What's 50,000 plus 50,000? 100,000. Very good. What's 5,000 plus 5,000? What's 500 plus 500? Okay, so that's 1,000, right? So comma goes there. What's 50 and 50? What's 5 and 5? Oh, but wait, we got to add 1. So instead of putting a 0 there, right, because this gets you 1. 1 times 1 is 1. So we have 6 ones. That's easy to add in our heads. 3086, and then we just add 1 to everything. 4, 6, 9, 1, 3, 6. Christina, you have a question?
Like,
The negative exponent only applies to the x, not the 17. Negative exponent on x, not 17. 17 is still up top. Let me show you. Example. All right. 3 to the 8th, 2 to the 6th. Are they perfect squares? If they are, what number is squared to get 3 to the 8th? 3 to the 4th. 81, right? So that's 81 squared. So that's a perfect square. What number do you square to get 2 to the 6th? Yep, 8 squared, right? So how can we use that to factor this? Well, that means this is 81 squared minus 8 squared, right? Are you following me? That's the difference of squares. How do we factor a difference of squares? Conjugates. Apparently this giant number factors to 73 times 89. And that is the only way to factor it. So you would have to, if you like figured these out individually and subtracted them, you would then have a giant number, and you'd have to figure out what number divides that, and you'd be checking 1, 2, 3, 4, 5, and eventually you'd find 73. Wouldn't want to do that. All right. You got this one? Do it. What does this factor to? Is this, what is this?
You tell me.
It's the difference of squares. Ignore that. I need w squared and what? I need what and what? And now, as much as possible, what is this? So what do I need? Is this a difference of squares? No, it's a sum of squares, right? Sum of squares doesn't factor because you can't get rid of middles without a minus sign, right? So this is fully factored.
Yeah, I didn't do it as much as possible.
Mm-hmm. Yep. That's right. That's right. You should ask more questions. You're a really good thinker. You are. But you just don't like using your brain. You try to get through school by doing as little as possible, which is very possible. Like, it's so easy to get through school without actually thinking. Problem is, you come out a dummy. Well, yeah. All right, so that's it for the review. We're done? Awesome. I'm turning it off. And I'll start uploading the video.